Hello everyone. When all students stayed at home to do the online course, I today would like to introduce the theory that we use for many years, invented by Professor Shiang-Dong in Department of Aeronautics and Astronautics in National Cheng Kung University. We call it complex mechanics because all the variables we use in this book is in complex domain. I will introduce you later or in the later video. Professor Ciann-Dong, he invented this by himself, started by 1998, and he wrote this textbook. We say it's textbook because we had the course in our department. It's for graduate student. This is the first edition. We can see that is published in 2008. So the first one, I think, is published in 2003 or maybe 04, because we all took that course. And most students took this course were engineering students. So at the beginning, Professor Yang did introduce the classical mechanics and quantum mechanics briefly, because most students, they don't have the concept of quantum mechanics, and also they are not familiar with the Hamilton mechanics. So at the beginning of this chapter, Professor Yang introduced some part of these, and especially the Schrödinger equations and the probability interpretations. But if you're familiar with quantum mechanics, you can escape this. And the chapter 2 is about motion in complex space. Well, there is some reference. Well, I won't say a lot, but there are some references. Also talk about the motion, the particles' motion in complex space. We can find it in some different authors and different papers for many years. As back to the earliest, probably started by 1983, I think. And here is a basic concept of motion in complex space. And one particular important part is Bohmian mechanics, because lots of people think the complex mechanics is the complex extension Bohmian mechanics. But well, I have to say that is not exactly right, because Bohmian mechanics is different than complex mechanics. Well, in the future talk, maybe I will discuss what's going on and why Bohmian mechanics differs from complex mechanics. And the third chapter is foundations of complex mechanics. And at the beginning, we call this quantum Hamilton mechanics because it compared to the classical one. We all know that in classical mechanics we have Hamiltonian, and in quantum mechanics we also have Hamiltonian. But in complex mechanics we have a very special Hamiltonian, and maybe in later we can see the form of it. First, it is in complex space, and the second is it contains the quantum potential. And this chapter basically described the foundations of this theory, and also mentioned about I think the operators. Here's some examples. Operators. Okay, maybe next time. And in this book, well, I should say in this textbook, because it already published as a textbook a few years ago, and we have fundamentals and some examples such as quantum oscillator and ternary effects. Well, it becomes a ternary dynamics, not only effect, because we can use this theory to explain and to detail tell you how the electron or any particle can ternary a potential barrier. And then it comes to the wave-particle duality. This is a great argument in quantum mechanics. Which one is right? Is particle wave property, or the particle has particle properties? That's what we call wave-particle duality. And this chapter answers this question. Well, that's amazing, and also be published in Annals of Physics in 2005. And then is quantum chaos. I think most control field students probably heard about this chaos because it's a kind of phenomenon in a linear system. So we have the quantum chaos for one-dimension complex plane. And then it comes to the Feynman path integral theory. And we use the trajectory interpretation again. All right, so this is a basic fundamentals part of complex mechanics, and our course probably ends here. And what follows are some very interesting applications, and they all be published in several papers for the last 10 years. Okay, we have the quantum scattering and spin dynamics and so on. And the third part is a relativistic extensions, which have relativistic versions. Some people ask me, you talk about complex mechanics and quantum mechanics. How about the relativistic quantum mechanics? And yes, Professor Yang already discussed this as the third part. The relativistic quantum Hamilton mechanics always said relativistic complex mechanics. There are some topics, and then it comes to the quantum motions in general relativity. Well, this is a whole textbook, but because the version I got is the first ones, I do believe we have the latest one, probably the 8 or 9. I don't know. So if you are interested in this textbook, please let me know. I can forward the whole book file to you because I have no time to upload it to the archive. So if you're interested in particular chapter here, please just email me or leave the message below. Just let me know. I can email you the whole file. Yeah, because they are all be published in journals. Maybe you didn't heard that before, but it's already be published. So, but the journal paper just not completed or very skillful writing. Textbook will be much better. So just let me know. All right. Okay, I think today's online talking can be stopped here. So good afternoon, everyone. Have enjoyed time, and please stay at home. Behave good. And so let me go back to my paper writing. So see you next time. Bye bye.